All right. So this example or question is again related to the law of conservation of energy. And let's say how will it work. Things which we are going to see is pretty similar the way we have disclosing it for the other specific. The question says that there is a box and the weight of the box is how much? It is 200 newtons. It is being pushed so that it moves at a steady speed. This is pretty very important. Steady speed means V is constant. Speed is going to be constant, and when speed is going to be constant, what we are going to infer from it, we are going to take that change in kinetic energy will be equals to zero. Change in kinetic energy along the ramp will be zero through a height of how much? So there is going to be a vertical height, and this vertical height will be equivalent to 1.5 meters. This vertical height will be equals to 1.5 meters. The ramp makes an angle of 30 degree. This is already being shown in the question. The frictional force. So there is one frictional force which is acting, and let's say block is moving forward. So frictional force will be acting in the backward direction. That is of how much value? It is equals to 150 Newton. So this is how it works. There is a forward force acting on the block, and there is one frictional force which is acting in the downward manner, and it is, let's say, moving upward. क्वेश्चन क्या कह रहा है? क्वेश्चन ये कह रहा है व्हाट इज द वर्क डन बाय द पर्सन. You need to find out the amount of work done by the person. So in this specific case, how are we going to find out the work done by the person? So we know जो भी ये वर्क किया जा रहा है इस पर्सन से, this work is increasing its gravitational potential energy plus there is some work which is done against the friction. अच्छा, एक बच्चे ने शायद पूछा कि work done against friction का क्या मतलब होता है? कि for instance, if this block is being pushed forward, friction will try to negate this motion. It will say by move backward. So some more force is being exerted by this person, or a force का वो part कुछ ऐसा होगा which is going to overcome this resistive force. और वर्क डन का वो पार्ट जो इस रेजिस्टिव फोर्स को ओवरकम करने में लगेगा, दैट विल बी नोन एज वर्क डन अगेंस्ट द फ्रिक्शन टू मूव द ब्लॉक फॉरवर्ड. राइट. तो हमारे पास जो मेन इक्वेशन कहाँ से शुरू होगी कि जो भी वर्क डन है, दिस वर्क डन विल बी इक्वलेंट टू ग्रेविटेशनल पोटेंशियल एनर्जी प्लस द हीट एनर्जी और द वर्क डन अगेंस्ट फ्रिक्शन इज गोइंग टू टेक प्लेस. अब हमें ग्रेविटेशनल पोटेंशियल एनर्जी का तो पता चल जाएगा. ग्रेविटेशनल पोटेंशियल एनर्जी कम अप विद द फॉर्मूला. व्हाट फॉर्मूला वी आर गोइंग टू यूज फॉर द ग्रेविटेशनल पोटेंशियल एनर्जी? इट इज mgh. एंड द वर्क डन अगेंस्ट द फ्रिक्शन इज फाउंड फ्रॉम व्हाट? फ्रिक्शनल फोर्स multiplied by the distance of the ramp, whole distance of the ramp, and this distance of the ramp is not given to us. तो what is our main task is to find this work W. mgh तो सारी वैल्यू पता है, फ्रिक्शनल फोर्स का भी पता है, but we are not aware about the distance which is to be traveled. So distance हमें पता चल रहा है. distance कौन सा है? distance ये रैंप का यहाँ से लेकर सारा यहाँ तक वाला distance हमने find out करना है. And we know this is the vertical height. The vertical height given to us is 1.5 meter. और हमें एक और बात भी पता चल गई है कि ये जो एंगल है ये कितना है? दिस इज 30 डिग्री. तो हमने हाइपोटेन्यूस निकालना है. परपेंडिकुलर हमें गिवन है, परपेंडिकुलर की वैल्यू है 1.5. हाइपोटेन्यूस निकालना है, एंगल आपको गिवन है. तो हम क्या स्ट्रेटेजी यूज करेंगे? हम साइन अप्लाई करेंगे. साइन ऑफ 30 डिग्री इज इक्वल्स टू सम पीपल हैव, that is 1.5 divided by this distance d. So this distance d will be formed as what? This distance d will be appearing as 1.5 divided by sine of 30 degree, जो कि equate होता है 3 meters के. So this much distance will be equals to 3 meters. This much distance will be equals to 3 meters. तो अब हम इसकी वैल्यू प्लग इन करते हैं. तो हमारे पास इक्वेशन क्या है? W is equals to mgh plus frictional force into distance. So if we need to find out the W, mg is already there क्योंकि mg किसके इक्वल होगा, mass के. So whole of the mg is equals to, sorry, mg will be equals to weight. So mg will be equals to weight, it is equals to 200. Vertical height will be equals to what, 1.5, plus what is the frictional force, 150, and how much distance has been covered, 3 meters. So multiplying all of them, we are going to get an answer of equivalent to 750 joules. Is this understandable? Can anyone just tell me in my equation, जो starting equation मैंने law of conservation of energy की develop की, इसमें मैंने kinetic energy क्यों नहीं लिखा? Why I didn't wrote that work done is equals to gravitational potential energy plus kinetic energy plus work done against heat. Can anyone tell me about this thing? Yes, people, please make the session interactive.
Sir, because the question said that the speed was constant, and when the speed is constant, the change in kinetic energy is zero.
Wonderful. It says in question, it says that the speed is steady. तो जब भी इस तरह के एनर्जी रिलेटेड क्वेश्चन आए और वहां पे अगर लिखा हो स्पीड इज स्टेडी, वेलोसिटी इज कांस्टेंट या टर्मिनल वेलोसिटी, ऑलवेज टेक चेंज इन काइनेटिक एनर्जी एज जीरो. Do not use change in kinetic energy in your equation. Is this understandable? So our final answer for in this regard is going to be equivalent to 750 joules. So work done will be equivalent to 750 joules. Is this fine? Okay, आगे चल रहा हूं मैं. There is another question. Let's see another question regarding this. और उसमें भी सारा यही काम करना है जो अभी हमने किया. So let's practice another question related to it. Question says that there is a block. Its mass is how much? The mass is having the block is having a mass of 2 kg. It is released from rest on the slope and it is traveling 7 meter down the slope and it falls a vertical distance of 3 meters. So there is going to be a one vertical distance of 3 meters, and you can also call it again as your vertical height, and it is falling from top to the bottom. The block experiences a frictional force parallel to the slope. So this is the frictional force F of 5 Newton in the backward direction, and block is moving downward. And the अब हमें यहाँ पे distance already provide कर दिया गया है. The distance is already given to us, which is 7 meters. So 7 meter is the distance. Question says, what is the speed of the block after falling this distance? यानी कि जब वो 7 मीटर का डिस्टेंस कवर कर लेगा तो यहाँ पर स्पीड कितनी होगी? What is going to be the speed when there is going to be when the body is going to be fall downward? So again, we will be using what concept? The concept here we are going to use is the law of conservation of energy. What will be the concept that at this top, gravitational potential energy is maximum. So we are going to say that this loss in gravitational potential energy will be equals to, अब उसने कहीं भी steady speed का जिक्र नहीं किया, speed बढ़ रही है. We are going to say gain in kinetic energy plus, क्योंकि friction का उसने जिक्र कर दिया, तो we are going to say कि that some of the work is being done to overcome the friction as well. अब ये इक्वेशन से हम स्टार्ट करेंगे. इसमें हम देखते हैं वेरिएबल्स क्या होंगे. लॉस इन ग्रेविटेशनल पोटेंशियल एनर्जी विल बी सेट एज mgh. Gain in kinetic energy will be set as half m v square minus of u square plus what will be the work done against the friction? The work done against the friction will be equals to the frictional force multiply by the distance covered over the ramp. क्योंकि वर्क किसी भी तरह का हो, work will always be formed from its basic formula, that is force multiplied by distance. So in this regard, what we are going to do, we are going to, oops, sorry, we are going to do what? Mass. So let's see what is the mass of the block. The mass of the block is 2 kg. The value of G is 9.81. The height is the vertical height 3, and this will be equals to half. Mass is again how much? Mass will be equals to 2. Now we need to find out the final velocity, v square, initial velocity, though it is released from rest. So when it is released from rest, our initial velocity will be 0 plus what is the amount of frictional force acting? 5. And what is the distance being covered? 7. Distance being covered is 7. तो इन सारी वैल्यू ये 2 और 2 कट जाएगा. इन सारी वैल्यूज को जब आप सॉर्ट आउट करेंगे तो आपके पास स्पीड क्या बन जाएगी? योर स्पीड विल बी ऑलमोस्ट इक्वल्स टू 4.9 मीटर पर सेकेंड. Speed will be equivalent to what value? Speed will be equivalent to 4.9 meter per second. You tell me, people, is this understandable?
Yes, sir.
Right? So हमारी जो speed आ जाएगी, that will be equals to 4.9 meter per second. Shall I move on?
Yes, sir.
Okay. So there is another question, a basic question. Again, this question appeared multiple times in different papers. It appeared in May, June 2020 as well. It appeared in October, November 15 as well. So we can witness this whole question, what is happening over here. So let's read out the question. Question says, a trolley starts from rest at X. It's rolled down to Y and eventually comes to rest at Z. तो ट्रॉली है जो रेस्ट से स्टार्ट करेगी एक्स पॉइंट पे और वो मूव करेगी वाई पे और वाई से वो चली जाएगी जी पे. क्वेश्चन ये कहता है विच रो इज पॉसिबल समरी ऑफ द एनर्जी चेंजेस ड्यूरिंग दिस प्रोसेस. तो व्हाट आर द पॉसिबल समरी चेंजेस ऑफ द एनर्जी, वो हम देखते हैं. तो यस पीपल बताओ, व्हाट इज द एनर्जी विच इज प्रेजेंट एट पॉइंट एक्स? Yes, guys, please hurry up. Tell me what will be the energy present at point X?
Potential energy.
It's going to be GPE. So in short, we can also call it as gravitational potential energy. When it is moving down, so it is moving down. हमने बताना है इस पूरे प्रोसेस में कि जब वो x से y, y से z पे जा रहा है तो क्या एनर्जी टेक प्लेस कर रही है. तो x से y और फिर z. तो जब वो मूव करना शुरू हुआ तो पोटेंशियल एनर्जी चेंजेस इनटू काइनेटिक एनर्जी. And definitely when it is rolling down, so some of the energy is being converted in the form of heat as well. So what is going to be the correct option in this regard? When it is moving from X to Y, from X to Y, potential energy is changing into kinetic energy plus friction. And likewise, Y पे kinetic energy maximum होगी तो Y से जब वो Z पे जाएगा, so Y की जो kinetic energy है, it will be converting into potential energy of Z. So kinetic energy changes into potential energy plus the amount of heat when it moves from Y to Z. Is it understandable? So from X to Y, potential energy changes to kinetic energy plus heat, and from Y to Z, kinetic energy changes to potential energy plus heat. The correct answer in this regard is going to be D. बेटा there is a heat between Y to Z. मैंने आपको बोला ना करेक्ट आंसर क्या इसमें बन रहा है हमारे पास. The correct answer format will be D. Okay, moving forward. Okay, हमारे next term आ जाती है. Next term is known as power. Write down the definition for power. Power को आप multiple ways में define कर सकते हैं. Power is called as कि कितना work body कर रही है कितने time में. Right? How much work is being done on any object in how much time, that is known as power. या power को दूसरे वे में आप ये भी कह सकते हो, it is rate of work done. Either you can call it as rate of work done or you can call it as work done per unit time. या आप इसको यूं भी define कर सकते हो, it's a rate of energy conversion. So you can define it in any of the way. Right? So power की definition क्या है? The work amount of work done per unit time. Power is defined as amount of work done per unit time. और हमारे पास पावर का फॉर्मूला क्या आ जाता है? पावर इज इक्वल्स टू W over T. If we are stating it in terms of W and T, it will be written as power equals to W over T. And if we are relating it in terms of energy and time, so it can be written as power is equals to energy divided by time. So there can be these two formulas for the power. Power is work done over time. And if you are saying that power is the rate of energy conversion, so you can also write as power is equals to energy divided by time. So P is equals to W over T or P is equals to E over T. And its SI unit is equals to watts. As SI unit is equals to watts. And how we are going to define 1 watt of power? So 1 watt is defined as the power when 1 joule of work is done in how much time? In 1 second. So when 1 joule of work is done, yeah, 1 joule of energy is converted in a time of 1 second, we are going to say that power is equals to 1 watt. The value of power will be equals to 1 watt. So one of the basic formula for the power is what? Power is equals to work done over time. The other formula for the power is what? Power is equals to energy divided by time. So these are the two very important and mandatory formula for the term power. Yes, guys, shall I move on?
Yes, sir.
Okay. Next, another formula of power from the similar definition, from its basic definition. एंड ये डेफिनेशन, इसकी डेरिवेशन आपको एग्जाम में पूछी जा सकती है, सो मार्क इट प्रिटी वेरी इंपॉर्टेंट. दिस इज वेरी इंपॉर्टेंट डेरिवेशन. तो अनदर फॉर्मूला फॉर पावर कैन बी इक्वल्स टू, वी कैन ऑल्सो से पावर is equals to force multiply by velocity. Power is equals to what? P is equals to F into V. अब ये कहां से आया ये फॉर्मूला? इसको डिराइव करते हैं. हाउ shall we derive it? We know from the definition of power. Power is work done divided by time. And we can also call work done. Work done is what? Force into distance over time. And we know that distance divided by time will be giving us a speed. So we can also write it as F into V. So your 2 marks ki derivation, it has been seen in the paper several times. You must be knowing that power can be also found from a formula force multiplied by velocity. Another formula of power is force multiplied by velocity. So you can just state power in another term. Power is the product of force and velocity. Power is the product of force and velocity. Yes, guys, everyone is with me. So we are having another term for the another formula for the power. Power is equals to force multiplied by velocity. So if you multiply force with velocity, that will be equals to power. So multiply force with velocity, that will be equals to power. Multiply force with velocity, that will be equals to power. So power is equals to force multiplied by velocity, F into V. Force into velocity. Okay. So next, average power का क्या formula होता है? Total work done divided by total time taken, right? Instantaneous power का क्या मतलब है? यानी कि किसी एक वक्त के ऊपर, किसी एक instant के ऊपर पावर अगर फाइंड करनी है, वो किसके इक्वल होगी? Again, it will be given by the formula P is equals to FV. तो ये दो बातें आपने याद रखनी है कि power is given by force into velocity. आगे चलूं?
Yes, sir.
Okay जी, so let's see another question जो कि power is equals to force into velocity का concept use करेगा. So let's see this question. The diagram shows an arrangement used to find the output power of an electric motor. So एक इलेक्ट्रिक मोटर है आपके पास और ये इलेक्ट्रिक मोटर घूम रही है, चल रही है. जो कि पुली को रोटेट करवा रही है। ये मोटर है जो इसका रोटर मूव करेगा और ये जो वेट है वो अप एंड डाउन मूव करेंगे। क्वेश्चन कहता है द व्हील अटैच टू द मोटर एक्सल हैज अ सर्कमफेरेंस ऑफ 0.5 मीटर। तो ये एक व्हील है जिसकी सर्कमफेरेंस, पूरा गोल चक्कर जो है वो है 0.5 मीटर, and the belt which passes over it is stationary when weights have the values shown। तो जो values आपको show हो रहे हैं, one of the values 20 न्यूटन, other values 50 न्यूटन, ये जो दो values आपको show हो रही हैं, इन दोनों values को देखते हुए पता चल रहा है कि इस वक्त आपका जो ये wheel है, the wheel is stationary। ठीक है, the belt which passes over it is stationary when the weights have the values shown। Question says when the wheel is making 20 revolutions per second, when wheel is taking how much? 20 revolutions per second, हमने find out करना है output power। So 20 revolutions per second से हमें क्या information मिलेगी? हमें इसकी speed की information मिलेगी from the term of 20 revolutions per second। और हमें जो ये weights दिए हुए, इस weight से हमें किसकी information मिलेगी? फोर्स की इंफॉर्मेशन मिल रही होगी। तो ये जब ये व्हील रेस्ट पे है तो हमारे पास नेट फोर्स किसके इक्वल आ जाएगी? जो नेट फोर्स है वो हमारे पास आ जाएगी 50 न्यूटन माइनस ऑफ 20 न्यूटन। तो दिस विल बी इक्वल्स टू 30 न्यूटन। ठीक है, हम नेट फोर्स यूज करेंगे व्हेन एवर दिस व्हील इज एट रेस्ट। अब हमारा टास्क क्या है? हमने फाइंड करना है स्पीड को। हमारा टास्क है कि हमने फाइंड आउट करना है स्पीड को। तो उसने 20 रेवोल्यूशंस ली, यानी कि 20 दफा गोल चक्कर लगाया व्हील ने 1 सेकंड के अंदर। तो 20 रेवोल्यूशंस का मतलब क्या है? 20 टाइम्स इट हैज कंप्लीटेड द सर्कमफेरेंस। सो वन ऑफ द सर्कमफेरेंस इज 0.5। तो स्पीड हमारे पास क्या आ जाएगी? स्पीड विल बी इक्वल्स टू 20 टाइम्स ऑफ द सर्कमफेरेंस डिवाइडेड बाय टाइम। और कितने टाइम में ये सब काम हो रहा है? दिस इज हैपनिंग इन 1 सेकेंड। तो हमारी स्पीड क्या आ जाएगी? दिस विल बी इक्वल्स टू 20 इंटू 0.5। इट बिकम्स ऑलमोस्ट 10 मीटर पर सेकेंड। इट बिकम्स 10 मीटर पर सेकेंड। और अब हमने पावर फाइंड आउट करनी है। सो आवर पावर विल बी इक्वल्स टू फोर्स इंटू वेलोसिटी। सो फोर्स इंटू वेलोसिटी इज व्हाट? फोर्स हमारे पास 30 है एंड वेलोसिटी इज 10। It equates 300 watts. So the output power of the motor will be equals to 300 watts. Yes, is this question understandable? So in this regard, our correct answer will be 300 watts. Yes, people, tell me. Ji, is this concept understandable, students? How to find out the power? We have used the formula of power
Yes,
as
sir.
force multiplied by velocity. So always use the formula of power as power is equals to force multiplied by velocity. Force will be the net force, that is 50 minus 20, which is 30 newtons. And that 30 newtons will be multiplied with the speed. How we found the speed? We found the speed with respect to the revolutions. One complete circumference was having a distance of 0.5. So if it has rotated 20 times, so it means the total distance covered is 20 into 0.5. And in how much time it has done? It has done in 1 second. So 20 into 0.5 divided by 1, that will be its speed. So multiplying the speed with the force will give us power. So power, output power of the motor is equals to force into velocity. Output power of the motor will be equals to force multiplied by velocity. Output power of the motor is equals to force multiplied by velocity. Is this done?
Yes, sir.
Okay. So moving onwards, there is another question. Let's see this question, what it is trying to ask in this whole of a part. Question says, this is again an exam question. The diagram shows a lift system in which the elevator masses are M1, which is being partly counterbalanced by a heavy weight mass M2. So there are two masses. One of the masses M2 right? And there is another mass which is m1. So there is an m2 mass which is downward, m1 mass is upward, right? Question says, at what rate does the motor provide energy? So when it is saying that rate of providing energy, so rate of providing energy is representing what? Rate of providing energy is known as power. If we are talking about energy over time, energy divided by time is known as power. Energy divided by time is known as what? It is known as power. So power will be equals to rate of energy transfer. So it means कि हमें उसने directly power find करने को नहीं कहा, लेकिन eventually we have to find out the power. So what we are going to do? Rate means time, and energy, like how much energy is being provided. Energy divided by time is power to the system where elevator is rising at a steady speed. So again, it is moving with a steady speed, and the gravitational of acceleration, yeah, free fall is taken as g. So what formula we are again going to use? Formula will be equals to p is equals to f into v. So force will be the resultant force. So we can take the subtraction of the two weights. Let's say w1 minus of w2, and our velocity is steady. So this will be v. So we have to tell which expression is going to give us the answer for the power. The power will be equals to m1g minus m2g multiply by v. तो पावर का हमारे पास रिलेशन क्या आ जाएगा? m1 minus m2 into g times of v. So this will be the power formula we will have. And the correct answer is going to be T. So power given out by the motor will be equals to m1 minus m2 into g multiplied by velocity. m1 minus m2 into gv. Is this fine? Okay, shall I move onwards?
Yes, sir.
Okay, the last topic of this chapter is known as efficiency of a system. So you people are pretty aware what does the term efficiency means. Any of the system is going to be called as efficient. Yeah, best of the efficiency. What does the ideal system means, or what is the meaning of any of the device or any of the machine being near to 100% efficient? यानी कि जब भी कोई मशीन अपनी मैक्सिमम इनपुट पावर को यूटिलाइज करके एक मैक्सिमम यूजफुल आउटपुट पावर बना दे. So if maximum useful output power has been fetched from the given input power, the machine or the device will be called as 100% efficient, or the machine or the device will be called as maximum efficient. So what is the efficiency of a system means, how we are going to define it? So this is its definition. Efficiency of a system is the ratio of useful energy output from the system to the total energy input. तो एफिशिएंसी का हमारे पास फॉर्मूला क्या होता है? कोई भी सिस्टम अगर हाई एफिशिएंट होगा, इट मींस दैट मोस्ट ऑफ द एनर्जी इज ट्रांसफर्ड इज यूजफुल. और अगर लो एफिशिएंट सिस्टम होगा, तो इट मींस कि जो एनर्जी ट्रांसफर हुई थी वो काफी सारी वेस्ट हो गई, डिसिपेट हो गई. सो एफिशिएंसी जनरली परसेंटेज में निकाली जाती है. इसको एनर्जी के फॉर्म में भी फॉर्मूला लिखा जा सकता है, इसका पावर की फॉर्म में भी फॉर्मूला लिखा जा सकता है. So what's the formula of efficiency in terms of energy? Efficiency is equals to useful energy output divided by total energy input multiplied by 100%. So this is one of the formula for the efficiency. Efficiency is equals to input energy, useful input energy, output energy multiplied by 100%. This is one of the formula of efficiency. What could be the other formula of efficiency? Efficiency in terms of power भी लिखी जा सकती है. It is going to be, sorry मैंने उल्टा लिख दी. यहाँ पे आउटपुट पावर आएगी और यहाँ पर टोटल इनपुट पावर आएगी, EI. And efficiency in terms of power can also be written as the useful output power divided by total input power multiplied by 100%. Right? So efficiency can be found either in the form of energy or it can be found in the form of power as well. So this is the basic formula of efficiency which you should be knowing. Or this is all about the efficiency term. This is about the efficiency term. Efficiency is useful energy output power divided by total energy input multiplied by 100. And in terms of power, what it will be useful output power divided by total input power multiplied by 100. Is this fine? How to define efficiency? So efficiency of a system is the ratio of the useful output power to the total input power. Or efficiency can be said as useful energy output to the total energy input. चलो आगे. Okay जी, so let's see the basic examples of efficiency. What are these examples? And then our lesson probably is going to be ended up. So quickly हम ये चार examples हैं efficiencies की इसको solve करते हैं and then this class is going to be over. Okay, so there is an example being shown in front of you. A man lifts a weight of 480 Newton through a vertical distance of 3.5 meter using a rope and some pulleys. The man pulls on the rope with a force of 200 Newton and a length of 10.5 meter of a rope that passes through his hands. Question says calculate the efficiency of the pulley system. So how are we going to find out the efficiency of the pulley system? How are we going to find out the efficiency of the pulley system? So efficiency of a pulley system will be formed. अच्छा इस सेशन में भी 3 मिनट्स रह गए हैं तो प्लीज 3 मिनट्स में अगर 3 मिनट्स बाद दोबारा आपने रिकनेक्ट करना है जो लास्ट लिंक मैंने आपको भेजा था उसी पे. So let's find out the work done. Let's find out the work done by the man in pulling this. So work done by the man is actually your input energy. So man pulls a rope with what force? Force will be 200 and how much distance is being covered? 10.5. So 200 into 10.5 will be equals to how much value? This work done will be equals to 2100 joule. And what is the amount of work done? Work is being done when the weight was being lifted. That work done is equals to 480 multiplied by 3.5. It will be giving us a work done of 1680 joules. तो हमने एफिशिएंसी फाइंड करनी है तो एफिशिएंसी इन टर्म्स ऑफ वर्क डन भी होता है तो आउटपुट वर्क डन डिवाइड बाय इनपुट वर्क डन so it will be equals to what 1680 divided by 2100 and whole of the value let's say is being multiplied by 100%. So your final answer in this regard will be what? It will be 0.8 or it will be equals to 80%. The efficiency of doing work was nearly 80%. Is this fine?
Sir,
Yes, sir.
G.
sir, if we do state that it is 0.8, will it have some sort of SI unit?
No, beta, efficiency do not have any SI unit because it is the ratio between same quantities. जब भी सेम क्वांटिटीज के दरमियान रेशियो होती है लाइक वर्क डिवाइडेड बाय वर्क तो वर्क का यूनिट भी जाउल है ऊपर भी वर्क का यूनिट जाउल है सो जाउल जाउल कैंसल्स आउट so the ratio between the two
Hmm.
similar quantities will give us no units. Is this
Okay,
fine?
sir. Yes, sir.
Okay, so we are left with one last minute of this session. तो मैं यहाँ पे अभी मीटिंग ब्रेक कर रहा हूँ. आप सबसे रिक्वेस्ट करूंगा कि आप दोबारा री लॉग इन कर लें. इसकी नेक्स्ट फ्यू एग्जांपल्स को हम डिस्कस करेंगे.